All right, hi everyone. Today we are looking at rational inequalities. There are two sets of rational inequalities. There are the graphs, and then there are the equations. And so, the main difference from a rational inequality standpoint is that you have to be able to locate both the x-intercepts and the vertical asymptotes. More accurately, I would say the domain. But either way, they fit together. So let's start with a graph question. So let's say I have the graph of a rational inequality, a graph of a rational function. Excuse me. That looks something like this. So at -3, I have a vertical asymptote. At 1, I have an x-intercept. So the graph of my function might look something like this. I have another, it's -1. I have another asymptote at 2. And so the graph of the function will look like this. And then at 4, I have one last x-intercept. And so the graph of the function hopefully looks something like that right here. And so this right here is the graph of my inequality. What we have to first note, well, let's give it a name. Let's call it f of x right here. What we have to note is that this graph has two vertical asymptotes. One vertical asymptote right here at x equaling -3. Another vertical asymptote at 2. Okay, and then we have two x-intercepts. What happens is that at the x-intercepts and at the vertical asymptotes, it's possible for the graph to change sign. And so we have to be aware of all these points of division. So we need a question. The question stated as an inequality would be something like, when is f of x greater than or equal to 0? Well, in other words, when is this function positive? Two things to note. Whenever we have and what's what I'm looking for? Whenever we have less than or equal to, we have to use square brackets. Except at infinities and at vertical asymptotes. Again, to be more precise, it should be at where there are holes in the domain. Or, in other words, whenever the domain doesn't exist, you have to use parentheses instead of a square bracket. But anyways, f of x greater than 0 right here indicates that the function is positive. And a positive function is one that is above the x-axis. Because if I was to plot a point above the x-axis, the y-coordinate would be a positive number. So all these points right here, refer to locations or sections of the graph that has positive y-coordinates, while the graph is above the x-axis. So from -infinity until -3, and then from -3 to 1, -1, the graph is above the x-axis, and then from full to infinity, the graph is above the x-axis. And so that gives me our solution. So the solution comes entirely from investigating the graph of the function. So from negative infinity until negative 3. So in other words, open circle, shade. Between here and here, the graph is above the x-axis. But that vertical asymptote is a hard wall, so you got to stop right there. And then from negative 3 to negative 1, open circle, close circle. So the negative 1 needs to be a square bracket. Open circle from here to here. And then from close circle 4 to infinity. And that, my friends, will be the solution right here. Or for my inequality from the graph. Okay, let's try one where we are given an equation instead of the graph, and we have to solve the inequality. So, let's say I have x squared multiplied by x plus 1 divided by x minus 2 times x plus 5. And I want to know when this thing right here is less than 0. So when you are trying to when you try and solve this inequality, you need to create a sign chart. But the sign chart, you need to find the x-intercepts and you need to find the vertical asymptotes. Let's find the x-intercepts first. The x-intercepts come from the numerator. So you take the numerator, you set that equal to 0. X squared equals 0, therefore x equals 0. And then x plus 1 equals 0, therefore x equals negative 1. These are the two x-intercepts for the graph. The vertical asymptotes come from the denominator. So x minus 2 equals 0, therefore x equals 2. X plus 5 equals 0, therefore x equals negative 5. So this graph right here has 4 boundary values at 0, negative 1, 2, and negative 5. And so what we do is we insert all of these boundary values on a number line. And we use that to create our sign chart by splitting the number line up into pieces. It is useful to name each region. So the first region extends from negative infinity until negative 5. The next region is from negative 5 to negative 1. The next region is from negative 1 to 0. And then from 0 to 2. And then the last region is 2 to infinity. So now that I have this right here, I can go ahead and test each region. So I take a number and I use it on the graph itself. So I need a number between negative infinity and negative 5. Say a test point of negative 6. You take negative 6 and you plug it into the equation and you check to see if the inequality is true. That's going to be negative 6 squared multiplied by negative 6 plus 1 divided by negative 6 minus 2, then negative 6 plus 5. And I'm asking myself the question, yes or no, is this less than 0? Well, negative 6 squared is going to be a positive number. Negative 6 plus 1 is going to be a negative number. Negative 6 minus 2 is going to be a negative number. And then negative 6 plus 5 is again going to be a negative number. It's going to be negative 1. If you have three negatives, remember to check if something's negative or positive, you just need count the negatives. I have three negatives, so this whole thing is negative. And yes, a negative number is less than 0. So this right here is one of the good regions. I need a number between -5 and -1. Say, for example, -2. And I have to plug that -2 in. So it's going to be -2 squared, -2 plus 1, -2 minus 2, -2 plus 5. And then I do the same analysis. -2 squared is positive. -2 plus 1 is negative. -2 minus 2 is negative. And -6, oh, it should be -2, sorry. -2 plus 5, that is positive. Again, so I have two negatives, so the whole thing is positive. A positive number is not greater than 0. And so this is not going to be part of my answer. A number between -1 and 0. There are lots of them. I'll go with -0.5. So -0.5 squared, -0.5 plus 1, -0.5 minus 2, -0.5 plus 5. So the first one is positive. The first one is always going to be positive. The next one is positive. The next one is negative. And then the last one is positive. I have one negative, so the whole thing is negative. A negative number is indeed less than 0. That's true. And so therefore this will take a check mark. I need a number between 0 and 2. I know what you're thinking. You're thinking 1. So that's going to be 1 squared times 1 plus 1 over 1 minus 2 times 1 plus 5. And so that's going to be positive, negative, and positive. So the whole thing is negative. That is true. And so this one will get another check mark. And last one, a number between 2 and infinity. I'll take 10. Let's go for a simple number. Let's go with 7. So that's going to be 7 squared. Notice right here, I'm not using the fact that I don't have a calculator to aid me. I don't actually have to work each of these things out. I just need to know the sign. And then you analyze the signs. 7 squared is positive. 7 plus 1 is positive. 7 minus 2 is positive. 7 plus 5 is positive. So the whole thing is positive. And a positive number is not less than 0. So therefore, that's not the answer. So notice the more delicate features for these inequalities. They take a little bit more time and you have to be very careful. But really and truly, it's just finding the breakpoints and testing each of these regions right here. I would point out that the number 2 is a vertical asymptote, and the number -5 is a vertical asymptote. And the only reason I point that out is that if it was less than or equal to, these would still be parentheses. Vertical asymptotes and infinities are always parentheses. Anyways, my solution to my problem will be all the check marks. So open circle, open circle, open circle, open circle, open circle, open circle. So -infinity to -5 union, -1 to 0 union 0 to 2. Okay. Whew, that was a lot of hard work, but we have one more question that we need to work on. As this one question can give you fits. It's, I think, like the last question from 3.6. The question says f is a perfect square times x, and g is 1 over x, and they ask, when is f of x above g of x? And so when they say this right here, when is f of x above g of x, all they're asking us to do is to solve this equation. F of x is greater than g of x. And so that leaves us with 16x is greater than 1 over x. The problem with solving this equation right here is that you are tempted to multiply both sides by x. Unfortunately, well, you can do that, but you have to remember that x cannot equal 0 because this fraction right here has an x in the denominator. Its domain is x cannot equal 0. If you remember that fact, that's fine. But generally, to avoid that problem, what we do is we keep the fraction. So we take the 1 over x over to keep the equation set to 0. And then we find a common denominator. So we write this as 16 over 1. And we multiply this by x over x. And that leaves me with 16x squared minus 1 divided by x is greater than 0. And the top is a difference of squares. So this factors into 4x minus 1 multiplied by 4x plus 1 divided by x. And that's greater than 0. And now this becomes just like the equation we did a while ago. So we have to find the x-intercepts. 4x minus 1 equals 0. X is therefore 1/4. 4x plus 1 equals 0. Therefore x is equals to negative 1/4. And then your vertical asymptotes. That's the denominator set equal to 0. X equals 0. Again, this is the same right here. X equals 0 right here. And so we use those three numbers, 1/4, negative 1/4, and 0 to set up our number line, and thus our sign chart. So we have negative 1/4, we have 0, we have 1/4, that breaks up our number line into three pieces. The first piece, negative infinity to negative 1/4. The next piece, negative 1/4 to 0. The next piece, 0 to 1/4. And the last piece, 1/4 to infinity. Now that I have this right here, I have to test. Over here, I can use 2. A test point of 2. And so we'll plug it into the factored form. That's normally the simplest form to factor. Oh, sorry, negative 2. And so that's going to be 4 times negative 2 minus 1 times 4 times negative 2 plus 1 divided by negative 2. Now, 4 times negative 2, that's negative 8. Negative 8 minus 1 is negative 9, so that's negative. 4 times negative 2, that's negative 8. Negative 8 plus 1 is negative 7, so again, that's negative. Again, that's being divided by a negative number. And the question was, is it greater than 0? And of course, 3 negatives is a negative. A negative is not greater than 0. No, it is not. So this right here is not one of our answers. I need a number between -1/4 and 0. -1/4 is 0.25. I'm going to use 0.01. 0.01. So that's what I got to plug in. So that's going to be 4 times 0.01 minus 1 multiplied by 4 times 0.01 plus 1. And then that's going to be divided by, so it's negative 0.01. Negative 0.01. All right, so the first one is still going to be negative. The next one is going to be positive, right? Because negative 0.04 plus 1 is going to be a positive value. And of course, the denominator is negative. So that's two negatives. So that whole thing becomes a positive. And so then this right here is correct. On the other side, I'm going to use almost the same test point, 0.01, the positive one. Oh boy, I'm running out of space. So that's going to be 4 times 0.01 minus 1. That's going to be negative still. 4 times 0.01 plus 1. And then 0.01. So that's negative, positive, negative. That results in a, what? Oh, the bottom is positive, sorry. That results in a negative answer. A negative answer is not greater than 0, no. So yes over here. So this is a no. And then over here, I can use a test point of 1. So that's going to be 4 times 1 minus 1. 4 times 1 plus 1 over 1. That's positive, positive, and positive. And so therefore this is indeed greater than 0. And so this is a check mark. And so my solution, open circles. Open circles. Solution is -1/4 to 0 union 1/4 to infinity. Now, remember what I was saying earlier on is that if you multiply both sides by x, you'd have gotten that 16x squared is greater than 1. And you multiply both sides by x, and then you take the 1 over, 16x squared minus 1 is greater than 0. And that'll give us 4x plus 1, 4x minus 1. And the problem is you're losing that fact that x cannot equal 0. And so you're losing one of those points. And that's why you end up with the wrong answer. Because 0 right here is a breaking point, a boundary value. All right, folks. Hopefully that helps.